Hello, everyone. Welcome to Advanced Functions. Because of the length of this course, I will not be holding any review sessions. So I'm just going to dive right into the course when the semester begins. So this is why I'm making this video to review some of the key concepts you're going to need from grade 11 and grade 10 in order to be successful in advanced functions. So I picked out a few important concepts. Granted, this is not all the concepts you're going to need, but rather I found the most important ones that I'm going to go over. These skills you must grasp in order to be successful in this course. So what skills are we going to talk about? Well, we're going to talk about 5 different things here. We're going to start with function notation, and then domain and range, and then expanding and factoring, rational expressions, and finally trigonometry. Now, you're going to need all of these skills, but since the course is designed linearly, we're going to start with polynomials and rate of change, and then we're going to go into slowly rational expressions. Now, in the first unit, you're going to need function notations, domain and range, expanding and factoring. Okay, you're not going to need rational expressions until later. You're not going to need trigonometry until even later. So if you're short on time and you want to get ready for the course, focus on the first 3 concepts, and then slowly, if you have more time later on, review the other ones. Okay, if you must, pick and choose. So I'm going to go in order. I'm going to talk about all of these concepts so you guys are well prepared for the course. So without further ado, let's begin. So the first concept we're going to go over will be function notation. Well, what is function notation? Well, this is something new that you've learned in grade 11. And notice that the name of the course is Advanced Functions. And in grade 11, the name of the course was Functions. So it has to do with functions quite a lot. And what is functions? Well, a function is basically the same thing as y. It is synonymous. It's just basically a fancy way of saying y, right? So if you have an input like x could be any number, you put it in the function, it will spit out another number, and that is f of x or y. So we will be using function notation basically from this point onwards. Why? Because there are some advantages to using function notations, f of x, instead of using y, and we'll be talking more about that slowly throughout the course. One of the advantages is that you can substitute values into your function notation, and that allows us to do more math. What do I mean by that? Well, if you take a look at this function in the middle of your screen, this is a generic function. This is a general form. It doesn't have any values. It's basically just f of x, except you have these parameters. Now, what are the parameters? Well, you have a, you have k, you have d, and you have c. Remember those when we learn about transformations and graphing? Well, a is vertical stretch, k is horizontal compression, d is horizontal translation, and c is vertical translation. All of these do something to the function. And the f, the f, well, that's just the function itself, f of x, and f of x could be anything. It could be a quadratic equation, it could be a square root equation, it could be a rational 1 over x, and it could be sine, it could be cosine, it could be like log, which you'll learn in this course. So it's just a placeholder. It's not anything until you put a function in there. So basically, a, k, d, and c are values that you can put into your function, and it does something to it. All right. So this is something that we'll learn again in grade 12. You're going to learn how to draw graphs using transformations again. So because this is covered in the course, I'm not going to review it here, and I'll just focus on something else. So what will I be focusing on? Well, mostly we'll be focusing on how to substitute values into the function, because the skill is extremely important in understanding many things we will learn in the first unit in advanced functions. So let me give you some examples. If you want to try these examples on your own, you're welcome to do so. Just pause the video and do the problem, and then just keep watching for the answer. I'm just going to go through these examples. All right. So the first one, you have f of x is x squared minus 2x plus 1. It is asking us to find f of negative 2. Okay, evaluate or simplify. In this case, we are evaluating. Okay, how do we go about doing that? First of all, what does it mean, f of negative 2? Mind you that this thing is not multiplication. This isn't f times x. I know in math, brackets means multiply. Well, in this case, this is just a symbol. This is f of x. This means y. Okay, again, this is synonymous to just saying y equals to x squared minus 2x plus 1. So you're not really multiplying anything on the left side. There is no math to be done on the left side. So all the math that is to be done is on the right side of the equation. All right, how do we do this? Well, notice that instead of f of x, you have f of negative 2. Okay, let me highlight your x's. So that one is red. I'll use red for all the x's. Well, guess what? In the function, instead of x, it says f of negative 2. So what do you have to do? All you have to do is replace all the x's with the negative 2, which means x equals negative 2. Basically, this is asking you, what is y when x is negative 2? So all you have to do is just plug in x into your function, and you should have the answer. So let's actually just do that. I'm going to first copy the question down. So f of x is equal to x squared minus 2x plus 1. Okay, I'm going to use red and highlight all the x's again. There we go. Okay, so next step is I'm going to replace all the x's with negative 2 because x is negative 2. So f of, instead of x, I'm going to write negative 2. Yes, you replace the left side as well. Okay, so x squared. Negative 2 squared, right? Well, not quite. If you write this, you're going to make a mistake. Okay, you need to have brackets. If you don't have the brackets, you're only squaring the 2 and not the negative sign. Because the negative sign is basically saying it's negative 1 times 2. Okay, so if you want to square negative 2, you need to square the negative sign. Therefore, you need to put it in brackets. Okay, so make sure you have that, because otherwise you will get the wrong answer. Minus 2 times, well, there's negative 2 because x is negative 2 plus 1. Okay, see what I did there? I replaced all the x's with negative 2. All I have to do now is just evaluate. Negative 2 squared is positive 4. Again, if you didn't have brackets, you would get negative 4 in this step. Especially if you're using a calculator, you just enter negative 2 squared without the brackets. The calculator is going to say negative 4 because the calculator is just going to calculate exactly what it sees in the calculator. So it's not going to know that you want the negative to be squared. So please make sure you have brackets. Okay, negative 2 times negative 2. Okay, that's another positive 4 plus 1. Okay. So f of negative 2 is just 4 plus 4 plus 1, which is 9. There it is. And that would be the solution. Okay. So that's the first one. All we have to do is substitute the number into your function. Now, the thing is, it doesn't have to be a number that you substitute into x. You can substitute anything into x. You can substitute another letter. Like this one, f of a. Well, what is a? I don't know. A could be anything. It could be 0, it could be 1, it could be negative 7, it could be pi. Doesn't matter. So all we have to do is recognize that, well, I just have to substitute all the x's for a. So that means x is equal to a. All right, let's do it. I have f of x. I'm going to copy the question down. Okay. I'm going to make all the x's red so that I can substitute a in. All right, so next step, f of a is equal to a squared Well, I'm not using brackets for a squared because there's no negative sign, so it's redundant, times a plus 1. Oh, I just said I wouldn't use bracket, and I did. You don't technically need brackets because a is not negative. Oh, there it is. That's the answer. What did we just do? All we did was just, instead of writing x, we wrote a. Okay, that's literally it. You might be thinking, okay, what's the point? Why are we doing this? Well, this in itself has no point, but it is a crucial thing to understand how to do, because this will be part of something bigger that you will learn later. Okay, we're going to learn something called the factor theorem and the remainder theorem, which involves you substituting numbers, sometimes just a letter, into a function and evaluating. Okay, so this is a skill that you need to know in order to learn something bigger. Well, sometimes you can substitute an expression into your f of x. Okay, so in this case, you're substituting a plus h. Same thing, don't panic. Just because there's more stuff now, doesn't matter. I'm going to just make all the x's red. Now, this time, instead of f of x, I have f of a plus h, which means x is equal to a plus h. Okay, let's do it. Copying the question down. Equals to x squared minus 2x plus 1. Make all the x's red. Okay, so f of, instead of x, I'm going to write a plus h. That is equal to, again, okay, now I need brackets. Because you have a plus h, if you don't have brackets, you're only squaring the h. So minus 2, a plus h, plus 1. There it is. Well, you could expand it, right? Because this seems like you can just continue. Well, let's continue and see what happens. Let's expand. So a plus h squared is h squared plus 2ah plus h squared. And then you can distribute the negative 2. You would have negative 2a minus 2h, and then, of course, the plus 1. Is there anything you can do to cancel any terms? No, they're all different. So yeah, this is it. Again, you might be thinking, well, this is ludicrous. Why would I do this? Well, you're going to learn something called rate of change pretty soon. And this is one of the steps you need to do in order to calculate that. So this is a skill that you will need for this course. Basically, all you're doing is substituting x for a plus h. Okay, again, you can substitute x for anything. You just have to replace it and just do the algebra, and that's it. So this is function notation. Despite being one of the more important concepts in mathematics, this is actually quite easy, right? You just have to substitute it in. That's it. Like, don't let this intimidate you. Oh no, all these symbols. Just remember, all it means is f of x is just the same thing as y. If you're substituting a value for x, just replace all the x's with the value and evaluate. Okay, let's move on to domain and range. This is also something you've learned in grade 11. And if I recall, every year I teach this. This gave students quite the challenge because this is new. Right? Learning domain and range is like learning a new language, the language of math. So you're basically writing a sentence, but not in English, in math symbols. And that can be quite challenging. All right, so first of all, what is domain and range? Well, the domain is simply all the possible values of x. All right, so if you look at the picture, you have a curve. And recall that x is the horizontal axis. So the domain of that curve is all the possible x values on the curve, which is denoted by the blue line. So that, whoops, that didn't go all the way. So that's x, that's your domain. Range, well, that's just all the y values, right? And recall y is on the vertical axis. So you have the same curve, you have the maximum point and the minimum point, and yeah, the range is all of the values in between. Okay, so how do we denote the domain and range. Like I said, it's a language really. You have to write out the domain and range using specific terms and specific symbols, and we're going to review that. So there might be two situations. You can have a graph or you can have an equation. Let's look at the graph. Now the graph is a lot simpler because you can physically see the domain and range. Actually, hold on a second. I'm going to pause because my dog is being crazy right now. Okay, I believe we're back. Yeah, we're definitely back. All right, so as I was saying, domain and range on a graph, you can actually just look at the graph and see physically where the graph falls on your axes. So here's a circle, okay? And we're going to find the domain and range of the circle. So domain is all the possible values of x. Well, let's look. On the circle, the smallest value of x is -4, right? Look, it's right here. So -4. And the largest value on the circle is 6. Oh, there it is. X is between -4 and 6. Well, it's easy to determine what the domain is. Writing it out is the annoying part. And there are two methods of doing that. One of them is set notation and the other one is interval notation. So I'm going to show you both because people use them interchangeably, and you need to know both because, well, in the future when you do math, you're going to see both. So let's start with set notation. Okay, so how do you write the domain? Well, D for domain. You have to use a large squiggly bracket. That's the set notation bracket. You have to use that one. The brackets do matter here. You have to write x is an element of the set of real numbers. Okay, hold on. What is that? X, well, is x. What is that thing in the middle? Well, that's like a letter E, except it's round, like the letter C with a line in the middle. What does that mean? It means the element of. Okay, let me write that down. This symbol means the element of. In other words, it means x belongs to. Belongs to what? Okay, this thing. R with a double line. Real numbers. If you're asking what a real number is, remember like classification of numbers, like integers, whole numbers, rational numbers, real numbers. Real number refers to basically all the numbers. Any number you can think of is a real number, well, at least in high school. A real number could be positive, it could be negative, it could be 0, it could be a fraction, it could be a square root, it could be irrational, it could be like pi, it could be anything. All numbers that you can think of are real numbers, okay? Like the only time you're gonna deal with numbers that are not real is when you're probably in university doing engineering, then you'll come into contact with imaginary and complex numbers, but we're not gonna go there, this is high school, so basically all numbers are real. And now why do we bother mention that? Like what's the point of saying x is all the real numbers? Well, there is a point. If you don't say that, then we don't know what x can be in terms of the possible values. Because it's not enough to just say x is between -4 and 6. Because like, think about this. If you're counting, let's say, apples, does it make sense to say I have 4.7 apples? I guess you can have like an apple with the piece bitten off, but like we're just gonna toss that. You're not gonna sell that, are you? So like you're gonna have a whole number, integer number of apples, right? So it can't be a decimal. So you would say then x is an element of integers, right? But in this case, if you look at the graph, it's a circle. There is no break in the circle. So x can be any number between -4 and 6, even the decimals. Can x be 1? Of course it can. Can x be 2? Yeah. See, between 1 and 2, right here, there are actually, in here, there are infinite numbers. 1.1, 1.2, well, you can have 1.11, you can have 1.12, 1.187. There are literally infinite numbers between 1 and 2, and x can be all of them. Okay, so that's what we have to mention, that x is an element of the real numbers, telling us that x could basically be a decimal, could be anything, which means the graph is continuous, okay? Well, there are restrictions though. It can't be all the real numbers, right? Remember, because it's only between a -4 and 6. So vertical line, this is, what is that? That means such that, well, that's literally English, such that, or but, x is between -4 and +6 and close bracket, okay? It does matter if you have the equal sign. So this is less or equal to. If you don't have the equal sign, then you're saying x is between -4 and 6, but x is not -4 and 6, which is wrong because look at the graph. X is on -4 and 6. So x can be those numbers. You must include them by using an equal sign. Okay, so that's how you use set notation for the domain. Let's see what I mean. It's like a language. All of these little symbols have a meaning. If you want to read this out loud, it says the domain is x is an element of all the real numbers such that x is between -4 and 6 inclusive. Yeah, that's what it means. Now you probably don't like that. A lot of people prefer interval notation because a lot of time is shorter, but actually, a lot of people also prefer set notation, apples and oranges, I guess. So how do you write this using interval notation? Well, x is an element of the same thing, except this time you're going to use these kind of brackets, square brackets. I'll explain why I'm using square brackets pretty soon. So from -4 to 6, right? Because x is between -4 and 6. So those bracket now means from and to. Okay, so in common language, this is from -4 to 6. Basically, x is between them. Now, why the square brackets? Square brackets mean inclusive. You are including the number 6 and you're including the number -4. Why? Because x can be those values. If you don't use square brackets, you wouldn't be including those numbers and you will be wrong. So brackets do matter. Now, what's the other kind of bracket? Well, if you wrote this, well, if you wrote that, then you're wrong. Because you'd be saying that x is between -4 and 6, no problem, but you will be excluding -4 and 6. You're saying x can't be -4 and 6, which is incorrect because look on the graph. X is obviously including -4 and 6. So you must use square bracket. It is not a matter of preference. These are symbols that have meanings. Okay, so you can't pick your favorite. You have to use the correct brackets. So that's interval notation. It is an interval from -4 to 6, inclusive square brackets. Okay, let's talk about the range. So let's go to the graph. What is the maximum value vertically now? Oh, it's 3. The minimum value, well, that would be -7. So on circle, the range, the vertical axis, well, where does the graph exist? Is between -7 and 3, including those two numbers. Okay, so let's just write the set notation. So range R, squiggly bracket, Y, because you're the range, the Y values is an element of the real numbers, because again, you can be between -7 and 3, including all the numbers, even the decimals, the irrationals, so hence the real numbers, such that it's from -7 to 3. You have to use equal signs because you can be those numbers. Okay, now what about the interval notation? Well, Y is an element between -7 and 3. And again, I use square brackets because you got to include those numbers because they're on the circle. Okay, so that's how you do domain and range. The hard part is to write the proper notation. Okay, but like to find what the domain and range is from the graph. Okay, that's not too bad. What if you don't have a graph, like the example on the right? Okay, let's take a look at that one. F of x is x squared plus 1. You know what you could do? You could graph this. If you know what the graph looks like, you can easily make a little sketch. I happen to know what this graph looks like. That's just x squared moved up by 1, right? So vertical shift of 1. So it looks something like this. And of course, the vertex has 0, 1. All right, so I just made a quick sketch. From the sketch, you can see, well, this is positive infinity. This is negative infinity on the x-axis. You can see that the graph goes to the left forever, and the graph goes to the right forever. So you can tell that x can be anything. So there's your domain. Okay, so right domain. So d is equal to x is an element of the real numbers. Yeah, that's it. No buts. That's it. X can literally be any real number. Okay. Well, you might be thinking, wait. What if I don't know how to graph this? You can still do it. You have to use reasoning to figure out that x is all the real numbers. Now, how do you do that? Okay, let's look at the equation. X squared plus 1, right? So what's happening to x right now? Well, x is going to be squared. Okay. Can you think of a number that cannot be squared? Meaning that if you try to square the number, you will break math. It's just not going to work. It's like dividing by 0. You break math. Is there such a number that cannot be squared? No, there isn't. Any number can be squared. You can square a positive number. You can square a negative number. You get a positive number at the answer, but you can square it. You can also square 0. 0 squared is 0. So there isn't a number that you can't square. And also you have to plus 1 at the end. Well, you can plus 1 to any number, right? So that means x can be anything. There's no restriction. Okay, that's it. The integral form, x is an element of, well, it goes from negative infinity to positive infinity. Wait, I'm using round brackets now. This is exclusive. Why am I using round brackets? Well, because x can't be infinity. Because infinity isn't a number. Infinity cannot be reached. You can keep adding 1, but you'll never reach infinity. Infinity is a concept. It's not a number. You can't really do math with infinity here. Okay, so that's why we exclude infinity. So x ranges from negative to positive infinity, but they can't be infinite themselves because that wouldn't make sense. Okay, so always exclude infinity using round brackets. All right, so the range is a bit trickier because the range is what the function will equal to. The graph, well, it's not that bad. Just look at the graph. You can see that there's a minimum at y equals to 1 and a maximum at infinity. Right, so that's positive infinity, that's negative infinity. So y ranges from 1 to positive infinity. All right, cool. Let's write that. So range. So y is an element of the real numbers such that y is bigger or equal to positive 1. There it is. Okay, make sure you write bigger or equal to because y can be negative 1. Again, well, I don't know how to graph this. How can I do this without the graph? Well, you're going to have to use reasoning. Now, this is a bit trickier. Remember, the range is talking about what f of x can be. What is y? So you got to calculate it. Is there any smallest value that this can have? Meaning that, well, x squared, right? What's the smallest possible value of x squared? Well, any number squared is going to be positive, even if you square negative numbers, like negative 2 times negative 2 is positive 4. So any number squared is positive. So that means the smallest number possible for x squared is 0, because 0 squared is 0. So that's the smallest value. But then you got to add 1. So 0 plus 1 is 1. So the smallest possible value for f of x is therefore 1. So that's how you know what the minimum is. Okay, what about the maximum? Is there an upper bound to this function?
Well, not really, no. Okay, because you can square any number. That number can be arbitrarily large. You pick your favorite big number, like a million, a billion, a Googleplex, whatever. You can square any number, and then you can just add 1 to that number. You get just an even bigger number. So there's no upper bound. So this goes to infinity. There we have it. Now you know that y. So let's write that integral form. So from 1, you have to include 1 because y can be 1, to infinity, which you must exclude because infinity isn't a number. You have to use round brackets. I know, the brackets don't match. You have a square bracket and you end it with a round bracket. That bothers me too, but too bad. Like, this isn't about aesthetics. You have to accurately represent the situation with symbols. And yeah, you can use different brackets. Okay, just make sure you have the brackets correct. So that's how you write the domain and range if you're given an equation. So you need to be familiar with set notation and interval notation. Okay, so make sure you understand that. And that's all I'm going to talk about regarding domain and range. Okay, so let's move on to some algebra. Okay, sorry about that. Let's move on to some algebra, which is also extremely important. I will be doing quite a bit of algebra in grade 12. And all of these skills will be assumed knowledge. So I'm just going to go over them now. So let's start with expanding. Okay, so expanding is a grade 10 skill. What do we mean by expanding? Well, if you have two brackets multiplied together, you actually can expand the brackets and simplify it into something smaller. How do you do that? Well, the skill is called foiling. So FOIL. What does FOIL stand for? Well, F is first, O is outer, I is inner, and L is last. So first, outer, inner, last. What does that mean? Well, let me show you. So here is a question: x plus 4 times x plus 2. How do you do this? Well, first, what do we mean by first? Well, take a look at the x's. The x's come first in both of the brackets, right? You multiply the first terms together. Okay, I have x times x. The next thing, you can multiply the outers together. What do we mean by outer? Well, see the x over here and the 2, they're on the outer edges of this whole equation on the left and on the right. So multiply the outers together and add them. So that would be x times 2. And then inner, the 4 and the x are on the inside of the equation. So multiply the inners. So it's 4 times x. And then you have last. The 4 and the 2 are the last terms of the respective brackets that they're in. So you multiply the last terms together, 4 and 2. Okay, and then you just add them up. All right, let's simplify this. Actually, I'm going to use black. You know, I can't be bothered to change color every time. So x times x is x squared. X times 2, that is 2x. 4 times x is 4x. And then 4 times 2 is 8. Recall from grade 9, you can collect like terms. So that would be x squared plus, well, 2 plus 4 is 6. That's 6x plus 8. There it is. And that's how you FOIL. Okay, so just keep in mind, first, and basically solve any problems, or any problem that involves expanding. Okay, let's look at more examples. Again, if you want, you can pause the video and try these on your own. And when you're ready to see the answer, just keep watching. All right, so the first one. Expand and simplify. All right, cool. First, outer, inner, last. Let's do it. First, okay, so there's this. So I have 2x times 3x. Okay, that's my first. Outer, so plus 2x times 2. Enter. Plus -1 times 3x. And finally, last, plus -1 times 2. Now, obviously, you can just write -1 times 3x and -1 times 2. You don't have to write plus -1. I'm trying to show as many steps as I possibly can so that you're not confused. But when you're actually doing this, it's much faster if you just skip a few steps. Okay, let me just simplify this. So 2x times 3x, 2 times 3 is 6. X times x, that's x squared. Okay, next. 2x times 2, that is 4x. -1 times 3x, that is minus 3x. And -1 times 2 is -2. All right, you can collect like terms. So 6x squared, 4x minus 3x is just 1x. In math, you don't have to write 1 because it's redundant. Just say x and minus 2. There we go. That is our simplified solution. Okay, let us move on to the second one. So in the second one, you have 3x plus 1, the whole thing squared. All right, how do we do this one? Well, a lot of people make this mistake, and it's one of the most common mistakes students tend to make. What is that mistake? Well, if you see two things added together and squared, many people are tempted to just square both. You distribute the square in, right? And you would have 3x squared plus 1 squared, so that would be 9x squared plus 1, and that's my answer, right? No, this is completely wrong. You can't do that. Okay, that's not how you do this. Why is that wrong? Well, let me show you with an example why that's wrong. So I'm going to find some space. Actually, I have space here. All right, so let's try this one. So 8 plus 1 squared. Well, that's an easy problem. I know you can just add up 8 and 1 because of that math. Let's not do that. Let's do it the mistake way. Let's distribute the square in and see what happens. So you would have 8 squared, right, plus 1 squared. Okay, 8 squared is 64. 1 squared is 1. So you have 64 plus 1. It is 65. Is that right? Okay, let's now solve the problem normally like we learned in elementary school. If you want to really solve this problem, you would have to add up the brackets first, right? So 8 plus 1 squared, how do you do this? Well, 8 plus 1 is 9. You would have 9 squared. And 9 squared is, 9 squared is 81. They're not the same, which means this method is wrong. Okay, this is a mistake. You cannot square the first and the last term when they're added together if the whole thing is squared. Okay, why is that wrong? Okay, let's go back to this. How do you actually do this? We learned this in grade 10. Remember there was a formula that we talked about? It goes something like this. So a plus b, right, squared. This is a squared plus 2ab plus b squared. And of course, if it happens to be a minus b, well, that sign becomes minus. But yeah, that's a formula that your teacher likely showed you in grade 10, and you're expected to then expand using the formula. Now, I myself memorized this formula, but I really don't like the idea of memorizing in math, because if you memorize formulas in math, you're not really learning math because you don't understand why. So it's much better to understand why this formula is the way it is, so that even if you forget the formula, you can just derive the formula, okay? So if you forget the formula, you can still do it, right? Because guess what? A plus b squared is just a plus b times a plus b, right? That's what the square means. You multiply by yourself. Let's just FOIL this. So that's a squared, b times a, right? Plus, well, a times b, inner, okay, plus b times a, plus b times 2b squared. And of course, ab and ba are the same thing because it doesn't matter the order when you multiply. So that would be a squared plus, well, because they're both the same, there's two of them, so the formula. So basically, if you forget the formula, which is quite likely because this is not exactly useful in your everyday life. If you don't do math, you're probably going to forget. It's okay. Just write them out twice, FOIL them, and you will always get to the answer. All right, so let's apply this to our actual problem. I'm going to erase the wrong answer here and solve this properly. Okay, I'm just going to use the formula because it's just faster that way. A squared, so 3x is our a in this case, so square that. Make sure you have the brackets though. If you don't have the brackets, you will only square the x, you will not square 3. Okay, 3x plus 2ab, so 2 times our a, which is 3x, our b is 1, plus b squared, okay, 1 squared. Let's simplify. So 3x squared, so 3 times 3 is 9, x squared is x squared. That would be 6x, right? Because 2 times 3 is 6. Well, you can just ignore the 1 and just slap on the x. 1 squared is 1. Okay, this is our answer. Okay, that is very different from what we got before. Actually, let us go back and do this using the method we learned in grade 10. So 8 plus 1 squared. Okay, a squared plus 2ab, so 2 times 8 times 1, plus b squared, right? 8 squared is 64. 16 plus 1 squared is 1. What do we have? So 64 plus 16 is 80, plus 1, oh, is 81. Now you see, that's why the formula works. If this still kind of confuses you, let me really beat this horse to death here. Because you're in grade 12 now, right? You may have learned grade 11 biology. Now, if you haven't, just ignore this part of the video and just skip ahead. But if you have learned grade 11 biology, you actually did learn this in biology. Now, your teacher probably didn't say it was math, but it is if you learn Mendelian genetics. So let's say you have a trait, around dominant recessive traits. I don't know. I'm just going to make one up. Let's say you curly hair versus smooth hair. Yeah, curly hair is dominant, smooth hair or straight hair is recessive. Let's say, okay, let's see. No, this is a terrible Punnett square. You don't actually need this one. Oh God. Okay, let me try again. Okay, that's much better. You put your alleles in here. Let's say that's a sperm and that's the egg. Well, you have 2 heterozygous individuals, and you're supposed to figure out, well, if 2 heterozygous individuals mate, what are the possible offspring? Well, you can answer this by drawing a Punnett square. And then just fill out the Punnett square by just crossing the alleles into the boxes, right? So big A, they both go into this box. And the one on the bottom is big A and little a, and the one to the side is big A, little a, and finally, that one is little a, little a. All right, cool. So you learned that the genotypic ratio is 1 to 2 to 1, and the phenotypic ratio is 3 to 1. Well, you don't need to know that for advanced functions, obviously, but let's think of it as a math problem. Big A, okay, there's one of those, right? Let me color code this to help you see it. And there's big A, there's one of those, plus little a, big A, that one. Oh, there's 2 of them. So plus 2, big A, little a, so color that. And finally, little a, there's only one of those. Okay, color code that. Hey, would you look at that? Isn't that just a squared plus 2 big A, little a, plus little a squared, which is the same as the formula you learned in grade 10. So what this is saying is basically you're taking big A, little a, and you're squaring that. Well, makes sense because you're multiplying by yourself because both parents are big A, little a. So this is actually hidden in biology. This is math. You may not realize this. So yeah, math is actually quite prominent in biology. We try not to talk about it because that's not the real focus here. But yeah, this is how math can be useful in real life. So anyway, that's enough about bio. Now, if you haven't taken bio, sorry about that. But if you have, I hope this helped a bit. Okay, let's move on. Okay, I spent a lot of time on that. The reason is that is a very common mistake. I will hate to see you make that mistake in grade 12. So yeah, please just keep that in mind. Okay, this one. Same thing, FOIL. So 2x times 2x. So plus 2x times -3. The next one will be 3 times 2x. And then lastly, plus 3 times -3. All right, let's just simplify. 2x times 2x, that is 4x squared. The next one, 2x times -3, that was a negative because there's a -3, right? So it's, oops, -6x. Okay, let me just cross them out as I do this. 3 times 2x, that 2 times 3 is 6, so that's plus 6x. And then 3 times 3 is 9, because there's a negative, is negative. Oh, look at that. These two cancel to 0 because you have -6x and positive 6x. So this ends up being 4x squared minus 9. Done. Actually, this one is another special thing that you learned. This is called a difference of square. So difference of square. What do you mean difference of square? Well, here's what I mean. Notice how this is a square. Because 4 is a perfect square, right? Because 2 times 2 is 4. This is also a perfect square because 3 times 3 is 9. So you have a difference because of subtraction, literally the difference of 2 squares. So this is called the difference of square. And there is a formula. A plus b times a minus b. You could FOIL this, right? Or you can just use a formula that is a squared minus b squared. Okay, this is something, again, I myself memorize. You should too, not because you have to, but your life will be so much easier when you do math if you have this formula memorized. Because this actually comes up quite often, and even in grade 12 math, you will see questions where you might see a squared minus b squared. You can recognize that immediately that's a plus b times a minus b. Again, I memorize these things not because, no, I'm a geek, although I kind of am, but because I did so many practice problems, I accidentally just remembered this. Yeah, that's what happens when you just do something over and over again. You remember whether you like it or not. It's like watching TV. There's a TV series and all of these characters have a name and you just kind of remember their names. Or if you're into like games or sports, just remember the names of the characters and the players, right? Not because you force yourself to memorize them, because you're so exposed to them, you just accidentally did. I know math is not as fun as watching TV and playing games and watching sports, but you got to put in the practice, and if you do, math will actually get a lot easier. And if you have all of these formulas and skills internalized, and it becomes intuition, math will be a lot easier and faster to do. Okay, and you probably find it more enjoyable as well as you learn harder material and you get to appreciate how beautiful math can be. Okay, last one for expanding. Okay, so this is a cube. 2x plus 3 cubed. Oh, well, cubed simply means you multiply by yourself 3 times. Okay, so the brute force way is just to write them out, FOIL, and then FOIL again. Now that takes quite a while, but it does get you the answer eventually. I'm not doing that, okay? Yeah, that takes too long. You did learn in grade 11 Pascal's triangle. Well, at least you should have learned Pascal's triangle if we didn't run out of time and skip that lesson. If you haven't, oh well, not a big deal. But if you have, you know exactly what I'm talking about, you can actually pretty efficiently solve that one. And also there is a formula. Again, I memorized it. You don't have to. It's convenient that if you know what the formula is. If not, you're going to have to do it the brute force way. Let me show you what the formula is. A plus b cubed. Well, that's just a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, if it happens to be a minus b, that one is negative, that one is negative. Yeah, that's it. That's the formula. Again, you don't have to memorize this. You probably won't even see a question like that, like a plus b cubed. That's quite rare. But if you do, you don't have to brute force your way. You can either use Pascal's triangle if you forgot how to do that, or you've never learned it. Here's a formula. So let's just try that one. So a cubed, so 2x, that's my a cubed, plus 3, 2x squared, b is 3, plus 3, 2x, 3 squared, plus 3 cubed. Okay. Now it's just a matter of simplifying. So 2 cubed is 8, x cubed is x cubed, plus, oh dear, 3 squared is 9, 2 squared is 4, 9 times 4 is 36. So that's 36x squared. Okay, so 3 cubed is 27 times 2, that is 54x, and then 3 cubed is 27. There it is. The answer is disgusting, but hey, we found it. Actually, we found it quite easily, huh? I just applied the formula and did it in my head. Well, you could get to this answer if you just foiled and foiled again, but I don't advise that. Okay, so that's all I'm going to say about expanding. This is actually one of the easier concepts because you learned this in grade 10. The next topic is factoring, which is basically reverse expanding. It's literally the opposite of expanding, and this is a lot harder. And you'll see why. Basically, you take the expanded form like this, and you go back into the factored form, back into the brackets. Right? How do you do questions like that? Well, there are two main types. If you look at the meme right here, on the left, you have ax squared plus bx plus c. That's just the quadratic formula, a quadratic equation, I mean. If a happens to be 1, congratulations, it's an easy problem. All right, the question like that, x squared minus x minus 30, that is trivially easy. Now, you might forget how to do this because it's been a while, but I guarantee if I show you how to do this, you'll be like, oh, yeah, I remember now, and you'll be fine. The one on the right, though, when a isn't 1, like a is 10, then yeah, that's a really complicated problem. It's a lot harder to do. And I'll be honest with you, if I see a problem like that and I'm supposed to factor it, I never will do it. I know how to do it. I just don't want to because it takes too long. It just takes too much effort for me to factor that. So I would just cheat out the answer using the quadratic formula. Unless the question, of course, literally says factor this, which you won't see. All right, because again, we're learning how to factor again because it will be part of a bigger problem. I'm not going to give you lower level problems anymore. So yeah, we're going to refresh our memories on how to factor. Okay, and by the way, we will be factoring in grade 12. It's just we'll be factoring x cubed in x to the power of 4. And actually, you can factor x to the power of n, and n could be any large number. It's just that it gets quite annoying when n is big. The question doesn't get harder. It gets a lot longer and very repetitive. So normally we just use examples when x cubed, x4, that's the highest power. There's no point in going bigger. You're just making the question tedious. In order to factor x cubed, you need to know how to factor x squared, right? So let's review how to factor. So how do you factor? Well, okay, let's refresh our memories. If x squared has a coefficient of 1, congratulations, easy problem. How do we do that? Well, let's see. X times x is x squared. So I'm going to reverse engineer the answer because I know when I expand the two brackets, I'm supposed to get the question back. So x times x is x squared. There. Must be that term. And m times n must give you the constant. Right? Think about it. C is just a number. M and n are just a number. They don't have an x. So a number times a number gives you a number. If you multiply by a number with x, you're going to end up with an x. You will have a variable. You won't be a constant anymore. So that means the only way to get c is to multiply m with n. So you can now conclude m times n is c. Okay. Okay, what about b? Now, b is a bit trickier. You're also going to have to multiply these together, right? So if you multiply x with negative n, you have negative xn. And then you have negative xm. You see what I'm saying? Because when you multiply the red ones together, wait, you can factor out negative x from here. You have n plus m. Give you the middle term. That's the only term with the variable x on it. Okay, so that means m plus n is equal to b. Ta-da, there we go. This is the ticket to solving the problem. Okay, so here's the rule. If you want to factor a trinomial, like x squared plus bx plus c, all we have to do is find two numbers that multiply to the constant, the last term. And also they add up to the middle term. And just plug it in. Let me show you with an example. So here's the first one. Again, if you want, you can pause the video. Let me just show you all the problems. You can just pause the video, try these on your own, and then when you're ready, just keep playing the video and see the answers. Okay, so here's my thought process. I'm going to factor this. First of all, I know this is a 1. Beautiful. This is supposed to be an easy problem. I don't have to bust my brain thinking about the answer. I just need two numbers, m and n, that multiply to negative 35. And also they add to negative 2. Now don't panic because the numbers are negative. That doesn't really matter. That simply means m and n, one of them is negative, right? Because if they multiply to a negative number, one of them is negative. So I know that the answer must look something like that because it's a bracket times a bracket. And also I know that they must start with an x because x times x is x squared. So when I factor, that's the first thing I do. Without even thinking, I write that down. All I have to do now is figure out what these numbers are. And that's just your m and n, right? So what is m and n? What times 1 is 35? I know 1 and 35 is 35. But then they have to add up to negative 2. So the difference between the two numbers must be 2. And obviously that doesn't work. Well, it turns out that 7 and 5 makes 35. Right? And the difference between 7 and 5 is exactly 2. So there, those are my numbers. But one of them is negative. Which one? Well, it must be the 7. Right? Because their difference is negative 2, which means the negative number is the bigger number. All right, so let's put it in. So x minus 7, x plus 5. This is our answer. See, that's it. Two numbers that multiply to the last term, but add up to the middle term. You can, of course, check your answer to see whether it's right. How do you do that? Well, just FOIL it, because foiling is a lot easier than factoring. Right, so I'm just going to copy the question and FOIL. Okay, x squared plus 5x minus 7x and minus 35 because 7 times 5. Okay, so x squared, that gives me negative 2x and negative 35. Is that the same as the question? Oh yes, look, same thing. That means we got it. That is the answer. All right, does that make sense, everybody? Okay, so let's move on. All right, what about this one? Whoa, there's an x cubed here. Oh, didn't I just say you learn how to factor x cubed in grade 12? Yeah, but you can still do this because you can get rid of the x cubed. Notice that everybody has an x, right? All the terms have an x. That is a common factor. You can just factor it out. Also notice that everybody's negative. Remember, you want the first term to be 1. Right now it's negative 1. That's kind of inconvenient, right? So why don't we just factor it out? So I'm going to factor out negative x. So the first term will be x squared. The second term, because I factored out negative, is positive now, so 13x. It's not x squared because I took out an x. 42, well, that becomes positive. Now the x is gone because I factored. We can still continue, right? Now this question becomes the previous problem. You just have to find two numbers that multiply to 42, but they add up to 13. What are the numbers? 6 and 7. X plus 6 times X plus 7. Because look, 6 times 7 is 42. 6 plus 7 is 13. And they're all positive because, well, all the numbers are positive. Right? Done. You might be thinking, what if I just can't think of the two numbers? Right? I'm not good at mental math. I just can't think of the two numbers. Well, you can just use a calculator. I'll take 42, just start dividing. 42 divided by 1, that's 42. 42 divided by 2, that's 2 and 21. 42 divided by 3, that is 3 and 14. You can just keep going until you find two numbers that add up to 13. And there, it takes a while, but you will get the answer eventually, which is why, again, I know I sound like a broken record, but you need to practice. Like, I factor very quickly. I'm not trying to brag, but I can basically factor questions like this in like 5 seconds because you have no idea how many practice problems I've done in my life. I'm at a point where it just pops into my head. So the more questions you do, the faster the answer will pop into the head. And that's just the way it is. Okay, so let's move on to more factoring. What about this one? Oh, x cubed again. Again, we learned how to factor x cubed in grade 12, but this question you can actually factor right now without learning grade 12 math. How? Well, let's factor out the x, right? No. This 2 doesn't have an x, so there's no common factor. Oh, crap. What do we do now? Recall something called factor by grouping. What do I mean by factor by grouping? I'm going to group the first two terms together and group the last two terms together. And then I'm going to factor them twice. So they do have common factors if you split them into two groups. So the first two groups, 3 and 6, you can factor out 3. X cubed, x squared, you can factor out x squared. So if you factor out 3x squared from 3x cubed, you just have an x left. If you factor out 3x squared from 6x squared, you have a 2 left. And I'm going to highlight this in blue. You see what I did there? Okay, cool. Now what? The second group, negative x, negative 2, I can factor out a negative 1, right? So that becomes x plus 2. I'm going to highlight this one, yellow. You see what I did there? So I just basically factored. Oh, wait. Take a look at this. X plus 2, x plus 2. They're the same thing. That is not a coincidence. Okay, I expect them to be the same. If they're not the same, you can't do the problem. So factor by grouping only works if you factor the two groups, you end up with the same thing. Now what we can do is we can factor out the x plus 2 from both terms because they're the same thing. So I'm going to take out the x plus 2. What would I have left if I factor out the x plus 2? Well, I would have these things left, right? So I have 3x squared minus 1, and that would be in green. And there we go. That's the answer. Look, you have something times something, and we're done. There's nothing you can do to factor 3x squared minus 1. That looks like a difference of square, but 3 is not a perfect square, so yeah. Okay, I guess you can do this. If you really want to, you can have root 3x minus 1, root 3x plus 1, because you can take the square of 3, it's just root 3, and just call it a difference of square, but this isn't really necessary because you'd be dealing with irrational numbers, and that is, yeah, that's messy. You are not expected to do that, so you can just stop right there. Okay, so that's factor by grouping. Actually, let me write the name here. Keep this in mind because this might come in handy in grade 12. Okay, one last one. Yikes. The first term, A isn't 1. And this isn't intuitive. I'll tell you right now, staring at it, I don't know what the answer is. It's not coming to my head. You're going to have to follow certain steps And I personally would just cheat out the answer using the quadratic formula. I'm not going to waste my time on this, but since we're learning, I'm going to teach you how to actually do this. Again, if you look at your textbooks in grade 10 and grade 11, you actually learned this in grade 10. This is something really difficult for grade 10s. The textbook actually gives you many strategies to solve them. I hate them all. I looked at them. I'm like, those strategies confuse me more than it helped. Now, one of the strategies, though, decomposition, I like. The other ones are utterly confusing. I'm going to show you decomposition. All right, how do you do this? Oh man, do I even remember? Okay, so you take the first term, well, the coefficient of the first term and the last term, multiply them together. Okay, so, well, that's supposed to be A, that's supposed to be B, that's supposed to be C, okay? What is AC? AC is 3 times 24. Oh boy, what is 72? Did I do that right? Yeah, that's 72. Okay, cool, AC is 72. Now, take that 72, A times C. Okay, step 1, let me multiply AC. Step 2, find factors of AC. So 72. What are all the factors of 72? Now, sometimes the question is easier, sometimes it's harder. Like 72 is awful because it has so many factors. 2 and 36. Oh boy, 3 and 7 divided by 3. That's the 2 and the 4. 3 and 20. Oh man, can this divide by 4? Probably. Yeah, that would be 18. This can't divide by 5. Can it divide by 6? Yeah, probably. So that's 12. Can you divide by 7? Probably not. 8. Yeah, 8 and 9. Yeah, that's it. These are all the factors of 72. Great. Step 3. Find a combination. Find a combo that adds to the middle term B. All right. I'm gonna use my highlighter here. I'm gonna highlight B, which is 17. Which combination gives me 17 when added? Obviously 8 and 9. Okay, congratulations. This must be that one. Okay, what do we do next? Back to the equation. Factor by grouping. So you decompose 17 into 8 and 9. So plus 24. You see that right there? Okay, let me fix a bracket here. Because get this, 17 is equal to 8 plus 9, which is why we picked that out of all the possibilities. Now, it doesn't matter if you put the 8 first or the 9 first. It works out the same eventually. All right, cool. Factor by grouping. So these two are in a group. Those two are in a group. Okay, factor out 3 and 8 has no common factor, but you can take out an x, so that's 3x plus 8. Right? 9 and 24, you can take out a 3. Yeah. So that would be 3x. 24 divided by 3 is 8. Oh, look. Same thing. 3x plus 8, 3x plus 8, right? And then you're left with x and plus 3. Again, this is not a coincidence. You can factor out 3x plus 8 now, and you will be left with x plus 3. Oops. And congratulations, you finally found the answer to this awful question. Okay. Yeah, that took a while. Oh yeah, I forgot a label. Okay. Decompose B. And then step 5, factor by grouping. And then you get the answer. Yeah, I personally don't like this method because it just takes too long. Now, the good thing about this is is very logical. You will always get to the answer if you follow these steps. The bad thing is it's just too long. So when I was in high school, I forget why, I don't think I paid attention to this when the teacher was teaching it, or maybe I did, I just forgot. So when I was doing my homework at home, I saw these questions, I'm like, what? How do you factor that? Right, so I looked at the textbook, didn't get it. So I tried to figure this out on my own, and I came up with a method that works for me. I don't know if it works for you. I'll show you the method anyway. I think it's just faster than this. But there is a caveat. You have to do a lot of math in your head, and you have to use your intuition. So let me show you my method for factoring this. It has some guessing in it, but it is not random guessing. It is educated guessing. Okay, so here's the problem, right? What do I do? I know the answer looks like that, right? And luckily, this number A is a prime number. A prime number means the only factors are itself and 1. So it must be 3 and 1. So 3x and x. Because this term must multiply to get me that. That's the only x squared in the whole equation. So it must be 3x and x. Now, it does get more complicated if that number isn't prime. Like if it's a 6, you have to debate, well, do I use 6x and 1x or 3x and 2x? Okay, so there is some guessing involved, and my experience tells me that's usually not 6 and 1. It's usually when they're closer together, you get the answer. But anyway, this is not this is a prime number, so 3x and x, no problem. So that just leaves this thing. Well, I know that those two numbers must multiply to 24, right? What could those numbers be? What numbers multiply to 24? Unfortunately, 24 has a lot of factors. Let me just list them. So 24 is 1 and 24. Obviously wrong, because, again, this is my experience saying if it's 1 and itself, the numbers are too extreme, you're not going to have the right answer. So obviously wrong. And you also have to multiply it to get 17. Yeah, 24 is already bigger than 17. Not going to happen. 2 and 12, 3 and 8, 4 and 6. Those are the other possibilities. Okay, so which one is it then? You have to, well, you have to think here. You have to somehow make a 17 in the middle, right? And you have to somehow use the 3. And so it probably is not a big number like 12. If you have a 12 in there, you're probably not going to get a 17. So let's try. So if you put a 12 here and a 2 here, I know for a fact this is wrong. Without calculating anything, I know this is not the answer. Okay? Here's why. Try to understand. If not, don't worry about it. Just use decomposition. I know this is wrong because 3 and 12 have a common factor. You can factor out a 3, right? You can just take out a 3. Wait, the original problem, this does not have a common factor. Look, 17 cannot divide by 3. So if your answer can factor out a 3 and your question can't, that means you're wrong. So this can't be the answer. Right? Same thing with this 6 right here. Yeah, no, they can't go together with the 3. You can eliminate those answers altogether. And of course, if you just switch the order, that's also wrong because you got to multiply 3 and 12. That is bigger than 17. You're wrong. So you can eliminate that. That is not the answer. Okay, likewise, you can eliminate the others, and eventually you end up with that. And I know this must be the 8, this must be the 3, because if you switch them, you have 3x plus x. You can factor out a 3, and this is the answer. And you can check by expanding. Look, I know there's a lot of guess and check. This is a bad example to use my method because 24 has a lot of factors. Very often, my method is a lot faster because you're not going to get crazy numbers like 24 with a whole bunch of factors. So you can quickly eliminate a lot of the answer and quickly get to the answer. Now, only use this if you're really comfortable with doing math in your head. If not, I suggest decomposition. And okay, you know what? In fact, I avoid questions like this altogether. I just use the quadratic formula. All right. So unfortunately, you do have to know how to factor these in. Yeah. Thankfully, though, these questions are rare. Okay, so that was a long time spent on factoring, and factoring is very, very important in math, to say the least. So many operations that you will learn in the future involves factoring. Like this, so rational expressions. You learned this in grade 11 as well, and there's a unit on rational functions in grade 12. And yeah, you might need to do some factoring. Let's just review. A rational expression, well, it's just a ratio of two polynomials. We learned how to simplify rational expression. Okay, so we can take a rational expression and make it simpler. And this idea is predicated on the fact that a number, let's say x, divided by itself is always 1. Okay, and if you multiply something by 1, it doesn't change. Okay, of course, x can't be 0 because we divided by 0. So if you actually have this, you can just cancel them and end up with 1. So what does that mean? Let's say you have 4x over x. You can just cross out the two x's, because if you multiply by x and then you divide by x, nothing happened. Like you multiply by 7, divide by 7, you get the same thing. Which is just 4. You see how this works? It doesn't have to be x. It can be 4 times sine of x over sine of x. Well, as long as you're the same thing, you can just cancel them. You see, that's the idea of canceling. Okay, dividing the top with the bottom, if they have the same thing, they disappear. Because if you multiply something and then divide by the exact same thing, you did nothing. Okay, notice it has to be multiplied. If it's added, doesn't work. So when I teach this in grade 11, I really stress this point, but people still tend to make mistakes because it's just kind of confusing and abstract. Look at this one. This is one of the more common mistakes I see students make. We learn about canceling, right? If you see something on top and the bottom of a fraction and they're the same, you can cross them out because they divide to 1, right? All right, what can you cancel from this? Oh, look, there's a 4 and a 4 here. No problem, they're gone, so they become 1s. Oh, there's an x and an x here. So I have 1 plus 1 over 1. This is 2 over 1. This is 2. Wait, what? No, that is not 2. This is wrong. You can't do that. Common mistake. Okay, just because something is in the numerator and the denominator and they're the same doesn't mean you can just cross them out. You can only cross them out if one is multiplied, the other is divided. Notice that's not what the question is. I'm going to erase all this just so you can see the question better. Look, this x is being added. This x is being... Crap, that looks like an x. I'll write out the word. The x on top is being added. The x on the bottom is being multiplied. Multiplied. They're not the same thing. They don't cancel. Okay, well, technically this is being divided because it's in the denominator. So you divide by the x, but the x is multiplied to the 4 though. So think about it this way, okay? You have some money. Somebody gave you $10, so plus 10. And then you went to the casino. Well, you're not old enough, but eventually, I don't know. You go to the casino, you play blackjack, and you lose half of your money. Do you get the same money back, but like equal to before you got the $10? Probably not, right? If you had $100, you picked up $10, you have $110, and then you lose half of that, you have $55, you don't have $100. They're not the same thing. So you can't really cancel them. So what can you do? Nothing. You can do to this expression. This is already as simple as it gets. Yeah, there's an x and a 4 on the top and the bottom. You can't cancel anything. Okay, so resist the temptation to cancel. You have to understand why you can cancel something, because they're opposite operations, and overall they do nothing. Multiply by 4, divide by 4, you end up with the same thing again. No, not for this question, because you're not multiplying and dividing by 4. You're adding 4 and dividing by 4. Okay, not the same. So the rule of thumb is that if you want to cancel something, you scan the equation. If you ever see a plus sign or a minus sign, then you can't cancel it, because that entails that the terms are added, not multiplied. Okay, so please keep that in mind. All right, so let's actually try to solve some problems. Again, I'll zoom out and give you a chance to pause the video. Try to solve these problems and then continue for the answers. Okay, so we learned how to multiply, divide, add and subtract rational expression, right? Let's just do a review. How do you do this? Well, you could just multiply the top of the top and the bottom with the bottom, right? Because again, fractions are hard. Like, fractions is one of the most annoying things in math. There are just so many weird rules you have to follow. But like, multiplying fractions is easy. All you have to do is just multiply the numerator with the numerator, denominator with the denominator, and boom, there you have it. All right, so you could just multiply the numerator with the numerator and denominator with the denominator, but that makes it still complicated. So here's my advice. If you can factor something, do it. Oh, look, this thing can be factored. Right? You can take out an 8. You can take out an n. So that would be n plus, well, 3 over 8n. You see that? Okay. What can we cancel? There's an n on the top and there's an n on the bottom. Notice that there is no plus sign. Okay, there's a plus on here, but it's in the bracket. So in terms of the n, it is being multiplied to all the other terms on the numerator, and same thing in the denominator. That n is being multiplied to the 8. So you have multiply by n, divide by n. That cancels to 1. Like, you can just get rid of them. Same thing with the 8. Okay, so what do we have? What do we have? Okay, let's simplify. So I have 2 over n plus 3 times n plus 3 over 1. Remember, when you cancel something, they don't literally disappear. They become 1. So you still have to divide by 1. Okay. Let's multiply them. So you have 2 times, oh no, I shouldn't use red. You'd have 2 times n plus 3 over n plus 3. Aha! N plus 3 can then go. Because again, the n plus 3 is multiplied to the 2 and then immediately divided by n plus 3. So the answer is just 2. Okay, so be very careful when you cancel. All right, so let's try a division. Recall in, I think, grade 6 that you learned this. If you divide by a fraction, it's the same as multiplying by the reciprocal. So just flip the fraction and you can multiply. So x minus 6. Actually, I can factor the denominator. Let me x squared. So that would be x plus, okay, 23 divided by 3 is 7. X squared is gone. Okay, I think I factored it. Division, I don't like division. I'm going to use multiplication. If I multiply, though, I got to flip the second fraction. So see, I reversed the numerator and the denominator. Okay, so let's try to multiply them. So that will be x minus 6. Don't expand them yet. Just write them together. In fact, you don't even have to write them together. You can just cancel, but I want to be very clear. So notice that there's an x plus 7 on the top and the bottom. Heck, you know what? You could have just canceled like this. Yeah, you can cancel terms when they're not even on the same fraction if it's multiplication. Right? Because the idea is if they're multiplying together, they're going to be the same fraction when you multiply them, because you just multiply the numerator together and the denominator together. They might as well be the same fraction. So this is why you can cancel on another fraction. Okay, only when it's multiplied though. If it's added, different story. We'll see that later. So to be clear, I just multiply them together and then cancel. All right, so I would have, what color am I? Oh, okay. That would be x minus 6 over 3x squared. That's it. There's nothing else you can do. Yeah, there's a 3 and a 6. Yeah, there's an x and an x squared. Cannot cancel them because for the same reason as we discussed earlier, because of this negative sign here, x and 6 are subtracting each other. They're not multiplied to each other. So therefore, you cannot cancel. That's the answer. That's the final answer. You're done. Okay, so that's multiplication and division, which is ironically easier than addition and subtraction when it comes to fractions. So let's talk about addition and subtraction. You learned this, I think, in grade 6. When you add two fractions together, it is not as simple as just adding them together. You have to find the common denominator and then add them. Okay. Denominator. Okay. How do you find the common denominator when you have a letter like n in there? Well, don't sweat. The idea of a common denominator is that you have something that the other denominator also have. So, in order for n plus 8 to be the same as n minus 2, I'm going to need an n minus 2. And likewise, for n minus 2 to be the same as n plus 8, I need an n plus 8. Look, now they're the same, right? But you can't just do that. That's cheating. You're changing the equation. So how do you fix that? Well, you do the same thing to the numerator, right? Because look at what I'm doing. I am multiplying the same thing on the numerator and the denominator. So I didn't really change the quotient at all. I multiplied by 1. You see what I mean? So that's the trick. You can multiply anything to the equation if you multiply the numerator and the denominator by the same thing. Okay. A lot of students, I noticed, from this step, what's the next step? They just cancel them. Oh, look, they cancel. And they cancel them, and you're back to square one. I know you can cancel them, but that's not what we're trying to do. You multiply them in for a purpose. If you cancel them, well, that's silly. It's like you go to the bank, take out a loan, and then you immediately pay back the loan. What's the point, right? So we're going to do something with the things we borrowed. So now you do have a common denominator. So look, they're the same now. Now you're allowed to add the numerator together. So plus 5n, that would be n plus 8. Okay, so now notice that you can add the numerator, and well, you don't add the denominator, you just have the same denominator. Okay, you just combine them. Okay, you got a FOIL. So that would be 6n minus 12. And you FOIL that one. So that is 5n squared plus 40n plus 8n minus 2. Notice that I am not FOILing the denominator. Don't do that. You don't need to do it. If you do it, you're not wrong, but you are wasting time. The question does not require you to FOIL the denominator. Now, the only reason I'm FOILing the numerator is such that I can simplify it, because look, you have brackets plus a bracket. That's not okay. But the denominator is bracket times a bracket. That is already factored, nice and simplified. Don't touch it, all right? If you do touch it, again, you're not wrong. It's just, A, you're wasting time. Why would you do that for no reason? And B, if you actually make a mistake, well, you actually get the question wrong, so don't do it. Okay, so the numerator, I have 5n squared, 6n plus 40n, that is 46n, and then minus 12. Denominator, n plus 8, and minus 2. Done. Don't try to factor the numerator. Again, not necessary. This is good enough. Okay, so there we go. Again, find the common denominator, then add them together, expand and simplify. Okay, so the trick is to find the common denominator. So let's try another one. The final one, you have a subtraction this time. I know what you're thinking, or at least what some of you might be thinking. Oh, 7x and 7x, they cancel to 0 because 7x minus 7x, right? No, because the denominators are not the same. You must have the same denominator before you can do addition or subtraction. Okay, so in order to get the same denominator, you just multiply the denominator of the other fraction. Okay, x plus 4, well, I'm going to need x minus 6. And if you're x minus 6, I'm going to need x plus 4. And of course, you can't just do that. You need to do that to the numerators as well. Notice again, I didn't change the equation. Okay, you can now combine them. You have 7x, x minus 6, minus 7x, x plus 4. Okay, and the denominator, I just have x plus 4, x minus 6. Okay, does that make sense? Okay. From here, actually, there are two. See from here, the obvious thing is just to FOIL them. If you want to do that, no problem. That's exactly how you do it, and you will get the right answer. However, when you're doing math, always look for shortcuts and tricks. What do I mean? I mean, if you don't look for shortcuts, you will also get the answer. But if you look for shortcuts, your life is a bit easier. I like to always look for shortcuts and just cheat my way to the answer. Look, they both have a 7x, right? I can factor that out. So that would be x minus 6 minus, this is another bracket, x plus 4. Now, you might be thinking, why would you do that? I'll explain why I want to do that. Because I would much rather expand a -1 than a 7x. That's just me. You don't have to agree. I find doing this easier. So that's x minus 6 minus x minus 4. So that's x plus 4, x minus 6. And then all I have to do is simplify. So x and negative x cancel. So -6, -4 is -10. So that's negative 70x over x plus 4, x minus 6. And that should be the answer. I sincerely hope this is right because no one is here to check my answer. And if this is wrong, well, that's going to be embarrassing. But yeah, I hope I didn't make a calculation mistake, and these should be the answers. Okay, this video is getting quite long, so let's just move on. And the last thing I'm going to review is trigonometry. Unfortunately, this is probably the hardest thing. But luckily, though, we're not going to touch trig until around midterm. So if you've forgotten trig, you have time to remember. And also in grade 12, we're going to pretty much learn everything again, except we're going to learn it in another way, which you'll find out. But it helps tremendously if you remember grade 11 trig. Okay, so let's start with graphing. Here's a curve. By the way, this is y equals to sine x. We learned some properties about sinusoidal functions. Namely, I'm going to call it this. The amplitude, well, that's the amplitude, right? From the middle to the peaks or the valleys. So A is amplitude. In fact, you can calculate the amplitude. There's a formula, maximum minus minimum divided by 2. Okay. We also learn about that thing. That is the horizontal axis. That means the axis, the middle line that cuts the graph exactly in 2. Okay, and there's a formula for that as well. That is just the average of the max and the min, so max plus min over 2. We also learned the period. The period is basically how long it takes for one repetition. It's a period we call t, because in physics period is capital T for some reason. So t is the period. How do you find t? Well, okay, that one is 360 degrees divided by the value of k. I'll explain what k is a bit later. And then finally, the phase shift, D is phase shift. Now in physics, phase shift isn't D, but for sake of consistency in mathematics, D is horizontal translation, which is literally phase shift. I'm just going to use D. All right, so there are 4 letters, so 4 properties. There's A for amplitude, C for horizontal axis, K, not the period, and D for phase shift. And they all come together in the function. So y equals, color code time, A, F, oh, wow, that's an ugly F, F, K, I like blue, X minus D in purple, plus C. Okay, and by F of X could be sine X, or F of X can be cosine X. One or the other. Okay, so this is a general form for a sinusoidal function. You might have forgotten a lot about this. There's really 2 major things we're going to do with that. The first thing is, here's a graph, determine the function, or here's a function, draw the graph. I'm just going to show you one example of each. So again, I'm going to zoom out. If you would like, go ahead and attempt this on your own and pause the video. And when you're ready, just click play. All right, I'm going to do this. So the first thing, I'm going to do the first one, determine the function. Okay. I'm going to need the maximum value. So max is 2, and I'm going to need the minimum value. Minimum is -4. Why? Well, because again, the formulas I just showed you, all you have to do is figure out AKDC, plug it in, boom, there's your function, right? So what is A? A is the amplitude, which is max minus min over 2. Oh, I know what the max is. I just looked on the graph, so that's 2. The minimum is -4. Be careful, it's minus the minimum. So if the minimum is negative, you minus the negative number over 2. So that is 2 plus 4 is 6 over 2 is 3. So A is 3. Cool, we found A. You can just as easily find C, which is just the average, max plus min over 2. So the max is 2 plus the minimum over 2. So 2 plus -4 is -2. Over 2 is -1. So cool. C is -1. We're halfway done. Okay. Okay, what's the period? Oh man. Okay, let's look. The period is 1 repetition. The easiest way to find 1 repetition is from maximum to maximum or minimum to minimum. I'm going to pick maximum to maximum. So here's 1 maximum. Here's the other maximum. Well, how much is that? So from -2 to 6, so that means period is 8, right? Because from -2 to 6, it spans 8. Okay, cool. So T is 360 degrees over K. So I need K, right? So rearrange. So 360 over T. So I know what T is. T is 8. 360 over 8. I don't think that divides. Oh boy. 4. There's a 4. Oh no, it does a 45. Okay, it's 45. And then finally, we need the phase shift. What is the phase shift? Well, the phase shift is how much the graph has shifted to the left or to the right. Well, in order to know how much the graph has shifted, you need to know what the beginning of the graph is. Where is the beginning of the graph? Well, it depends on whether this is a sine graph or a cos graph. For your to remind you okay, so here is a sine graph. Here is a cos graph. I'm not going to bother labeling the numbers, but notice the sine graph starts on the horizontal axis. In this case, is 0. It starts in the middle of the graph. The cosine graph starts at the maximum. Okay, so it's up to you. If the question doesn't specify which one you must use, sine or cos, it doesn't matter. You pick one. So this question didn't specify. It just says find the function that models the graph. Well, I should say find a function that models the graph because there are multiple functions that can model this graph. All right, I'm going to choose cosine. 90% of the time, I made that statistic up. 90% of the time, cosine is easier. Why? It's much easier to find the maximum than to find the horizontal axis, the middle, because the maximum is easy to look for. Look, there it is. Ta-da, 6. I mean, okay, there's another one, -2. I'm going to go with 6. I like positive numbers. All right, so because I'm going for the maximum, this must be cosine. Okay, so d equals to 6 because I choose cosine. So my function, y equals a, I'm going to call it a is 3. I chose cos. K is 45. The phase shift, d minus 6, plus c. C is -1. Oh, I should say -1 then. There we go. Ta-da! There's my answer. Okay. Okay, so let's move on to the next one. Here is a function. Draw the graph. Okay, the first thing I'm going to do is I'm going to factor 4 out. 60 over 4 is, I believe, 15. Oh, my mental math is terrible. Yeah, it's 15. I'm going to factor out the 4 because I need that to match the general form. So this is A. This is K. This is C. And that's D. And I have a sine graph. Okay, so from this, I know that the horizontal axis is +1. Right, C is 1. I know that by looking at the question. What is the maximum? I know the amplitude is 2. So to get to the maximum, you just have to find the horizontal axis +2. Right, max. Again, amplitude is 2. The minimum, same story. Because the amplitude is 2, you just go from the horizontal axis. That's the minimum. Again, A is 2. All right, cool. I found the max and min. What about the starting point? Where does the graph start? Well, because this is sine, right? Sine starts in the middle. It starts in the horizontal axis. Oh, but wait. It's x minus 15, right? So the phase shift is 15 to the right. So you have to take that point and move it to the right by 15. Oh, man. 15 is here, right? Because 2 box is 16, 1 box is 30, so half of that is 15. Yeah, I'm going to erase that. There we go. So it starts there. You have to take the sine, which starts in the middle at 0, move to the right by 15. Oh, man. Okay, this is kind of hard to label. So D is 15. I hope you can see that clearly. Yeah, from the 0, you move to the right by 15. And because that's what it says right there. Lastly, the period, actually, I don't know what the period is. I know what K is. K is 4, right? But remember, period is 360 over K. So that is 360 over 4. That is 90. So the period is 90. So 15 plus 90 is here. Right, because I know if this is 90 plus 15, it must be there. And 90 plus 15 is 105. All right, cool. This is a sine graph, right? Again, the question is a sine. And we know what sine generally looks like. Look, this is sine, right? You have the beginning, you have a 0 right there, and the end, you have a 0 right there. But in the middle, you also have a 0. And then in between those, you have a maximum and a minimum. Let's reflect that on the graph. In the middle, so these are the two ends. In the middle, you have a 0. And in between them, you have maximum and minimum. So somewhere there is your maximum. Again, make sure you actually hit the maximum, right? And somewhere here is your minimum. Oh God, this is ugly. And all you have to do is just connect them there. Now, sine and cosine graphs, sinusoidal functions, they actually go on forever. So you can just continue the pattern. I'm too lazy to do that. I'm just gonna do this, and you can assume it goes on forever. All you have to do is just mirror the images, keep drawing. For the sake of time, I'm not gonna do that. So yeah, this is f of x equals to 2 sine 4x minus 60 plus 1. I hope it, again, I didn't make a mistake. Yeah, there it is. I hope you got the same thing. Okay, one last page. I know this is getting quite long. We need to know how to solve for angles using trig from 0 to 360 degrees. And this seems easy, right? Because in grade 10, you learn SOHCAHTOA. And to solve for angles, you just take the inverse. Like, for example, sine of theta is equal to, I don't know, 1/2. Then theta is simply the inverse sine of 1/2. And if you punch that in your calculator, you should get 30 degrees, right? Easy peasy. I mean, no. Sometimes, yeah, you get the answer, but mind you, in grade 10, all your triangles are acute triangles. All your angles are less than 90 degrees, so this works. But in grade 11 and grade 12, the angles are not necessarily acute. It means it can go from 0 to 360, so that method doesn't work. You have to use the CAS rule. All right, so what that means is, well, this is the Cartesian axis, by the way, the x and the y axis. Quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. This is 0, this is 90 degrees, this is 180 degrees, this is 207 degrees, and this is 360 degrees. You go around in a circle. And in each quadrant, the 4 letters, we call this the CAST rule, C-A-S-T. It tells you which sine, cos, or tan ratio is positive or negative in those quadrants. Okay, so the 4 letters represent the positive ones. Now, I don't like the name CAS rule because you have to start from the 4th quadrant, so I made up my own. All, A for all, students take calculus. Right, you go around 1, 2, 3, 4. I like that one better because you start counting at the 1st quadrant. So all students take calculus. That's how I remember it. You can make up your own. All means sine, cos, and tan. Everybody's positive in the 1st quadrant. S for sine, only sine is positive in the 2nd quadrant. T for tan, only tangent is positive in the 3rd one. And cos, only cosine is positive in the 4th one. I'm not going to go into too much detail as to the reasoning because, again, time. I'm just going to use the CAS rule and solve these problems. So solve for x such that x is between 0 and 360. So tan of x is negative 1/3. You don't just whip out your calculator and do inverse tan of negative 1/3. You will get the wrong answer. You'll get a negative number, and that is not between 0 and 360, right? So you have to use the CAS rule. How do you do that? Well, here's my Cartesian axis. All students take calculus. Okay, so tangent. Tangent is negative. Look, it's negative 1/3, right? So tan is negative. In which quadrants do you have negative tan? All students take calculus, right? So these 2 quadrants, you have positive tan because A, all, everybody's positive. T, tangent. Tangent is positive. Again, see, look, everybody positive. tangent positive. But our tangent is negative, so you can't pick those two quadrants, which means negative in these two quadrants. You see the logic here? Find the two quadrants that you have a negative tan, because this guy, negative 1/3, is negative. Okay. This angle is what we call x. We need to solve for this x. But wait, there's another one, because there are two answers. This is also x. So how do you do that? How do you solve for that? You have to use related acute angles. So if you look at this angle right here, I'm going to call it beta, because the convention is to call this beta, and that one is also beta. If you can imagine that there's a triangle here. Actually, let me just take that triangle and draw this here. This is a right triangle. This is beta, right? If you can take that and then just solve for beta, that'd be nice, wouldn't it? So that's exactly what we're going to do. We're going to solve for beta. Okay, and we know this is tangent. And tangent beta is equal to, well, it says negative 1/3, but we're going to make it positive. Why? Because it's a triangle. We're not going to consider the Cartesian axis anymore. I'm just going to take the triangle out of the axis and just call it a regular triangle, and triangles can have negative sides. So recall, tangent is opposite over adjacent. So yeah, the sides are 1 and 3. So tangent beta is 1/3. So in other words, if you have a negative number, if you're going to be talking about the acute angle beta, you make it positive, all right? So beta is the arctan of 1/3. So now you can just do your arctan. So whip out your calculator. Arctan of 1/3 is 30 degrees. Okay, I did that in my head because I remembered my special triangles. Again, this is not something you're supposed to memorize, but you should. Again, it makes your calculation so much easier if you remember your special triangle values. All right, so beta is 30 degrees. The question isn't to find beta, though. The question is to find x. So last step, what is x? Well, keep in mind that this is 180, right? So 180 minus beta is x. Do you see that right there? Look. The green is 180 right here. If you go back by beta, you get x. So that means x is 180 minus beta. I know what beta is. So x is 180 minus 30. X is 150. Okay, cool. There's another answer. Okay, look. If you go all the way around, that's 360 degrees. If you go back by beta, you get the other x. So 360 minus beta is equal to x. So x is equal to 360. Beta is 30. So x is 330. That's your second answer. There's almost always two answers. Sometimes there's one, but that's really rare. Most of the time, there are two answers. You need both answers. Look, it says solve for x when it is between 0 and 360. 150 is between 0 and 360. 330 is between 0 and 360. So there are two solutions. You need both. Okay, so that's how you do questions like this. Yeah, it takes quite a while. But yeah, please make sure you remember how to do this. We will be doing this again in grade 12 advanced functions, and the equations are going to look a bit bigger. Okay, let's do another one. Sine x is √3/2. So CAS rule, all students take calculus. Sine is a positive number. See, positive 3/2. So that means, all right, sine is positive. Where do we have sine positive? Well, in the first quadrant, everybody's positive, so of course sine is positive. In the second quadrant, it says S, sine is positive. So right there, this is x, This is also x. You have two values of x. Actually, I'm going to call that x1 and x2, just to be clear. Oh, I forgot to label that x1, x2. Well, oh, well. Okay, well, you're going to need the related acute angle. Oh, but wait, in the first quadrant, very conveniently, beta is x1. All right, so if you have sine beta, you would just have root 3 over 2. Again, if that number is negative, you make it positive. Since it's positive, no problem. So beta is the arc sine of root 3 over 2, and that is 60 degrees. Again, special triangle. Since in the first quadrant, beta is x1, because look, it's the same angle in the picture. Look, right there. So it's the same thing. So x1 is equal to 60 degrees. Done. Now, 180 minus beta is x2, because that's 180. You go back by beta, you have x2. So x2 is 180 minus 60, because beta is 60. So x2 is, that would be 120. Two answers. Okay. All right, moving on. We learned reciprocal trig ratios as well. So we have secant now. Now, secant, you don't have that button on your calculator. No problem. Let's convert it into sine, cos, and tan, which you do have a button for on the calculator. So recall that secant is simply 1 over cosine. So 1 over cosine is negative root 2. Cosine is in the denominator. So let's just negative 1 over root 2. See what I did there? I just split the fraction on both sides. Here we go. All students takes calculus. Cosine is negative. How do I know? Because that number is negative. Where do we have negative cos on the Cartesian axis? It's here and here. How do I know? That quadrant, everybody positive, because all. That quadrant, look at that giant C right there. Cosine is positive. Nuh-uh, our cos is negative, so it must be the other quadrants. Okay, x1, x2. You see where I'm going with this? This is getting repetitive. To solve for these, you're going to need the betas. So cos beta, because we're just looking at the acute triangle formed, beta, because it's a triangle, we don't care about the negatives. The size of a triangle is positive. So that's just 1 over root 2, right? Because we know its cosine is adjacent of a hypotenuse, so 1 over root 2. Look. All right, so with beta, well, beta is the arc cosine of 1 over root 2, and that is 45 degrees. Again, special angle. I picked special angles on purpose, so I don't have to whip out a calculator. Okay, cool. I found beta. Let's look at the drawing. How do you find x? Well, you can see the x1 is 180 minus beta. So x1 is 180 minus 45. That is 135. So boom, first answer. x2, again, look, x2. Oops. If you look here, it's 180. You have to go another beta in order to get to your x. So that is just 180 plus beta. All right. So beta is 45. So x2 is 180 plus 45. What is 180 plus 45? That's 225. Oh, okay, two answers. Last example for the whole review package. Cosecant. Recall cosecant is 1 over sine. That is -2. Flip both sides, so you have sine x is -1/2. Okay, same story. You have a negative sign this time, so sine is negative. So all students take calculus. It must be found in these two quadrants, because again, everybody, all positive. Sign positive. Well, we have a negative sign, so it must be in the other two quadrants. That's x1. That's x2. Okay. Betas, where are my betas? So that is beta. That is beta. So sine of beta is positive half. Again, we just care about the triangle. We don't care about whether it's positive or negative. So that means beta is the arc sine of half. So beta is 30 degrees. Well, if you don't memorize special triangle, just use a calculator. Okay, so what about x? So x1 is just 180 plus 30. x1 is 210. x2 is 360 because you got to go all the way around minus beta, minus 30. So x2 is 330, and there you go, 2 answers. Okay, so these 4 examples, if you forgot to do it, it might not be enough. So if that's the case, come talk to me in class and I'll give you extra practice, but I wouldn't worry about this for now. Focus on the first few things that we've learned because that's more immediate. We're going to dive into polynomials, function notation, and how to factor. That's the first thing we're going to learn. So this comes later. Okay, so that sums up the review. Now, there are many things that I didn't cover because it will be too long. So if you have any questions, you're welcome to ask me. But yeah, I hope this was helpful. You always have this video to fall back to if you forget. And there are many great resources on YouTube. You have your textbook, and you can just ask me in person. All right, so yeah, that's it for the review. I'm going to stop the recording. So good luck, everybody.